Look at this mathematical optimization landscape leveling out. You know how to do this. You have spent years training machine learning models and writing efficient Python code to minimize loss functions. Your academic background has successfully equipped you to parse complex statistical distributions and extract tight correlations from raw data. But there is a harsh reality waiting for you in the enterprise ecosystem. Despite all this technical capability, a massive number of corporate data science initiatives completely collapse. On the left, a clean pipeline flows from dataset to model. But watch the right side drop. 80% of corporate projects fail to deliver ROI. The flashing red gap reveals the truth. These failures rarely stem from bad code. The technical left side is flawless. The failure occurs because perfectly optimized mathematical solutions are being applied to the wrong business problems. To fix this, we need to shift your focus away from algorithmic optimization and address the specific point of failure. The overarching target is to master the foundational cross-industry step known as the business understanding phase. This requires unlearning, the instinct to obsess over hyperparameters, the external configuration variables, set before a model begins learning, and abandoning the habit of targeting pure accuracy metrics in isolated coding environments. In the modern enterprise ecosystem, technical execution without strategic business alignment guarantees a zero ROI output. This digital map of Malaysia shows pulsing data lines connecting directly to healthcare, agriculture, and smart manufacturing. This represents the My Digital Blueprint, which is driving a massive surge in enterprise demand for artificial intelligence, or AI. Notice how each sector node expands into an upward trending chart. The National AI Roadmap for 2021 to 2025 relies on integrating AI across these specific industries to generate hundreds of thousands of high-value jobs and massive economic output. Realizing a vision of this magnitude requires professionals who can bridge the gap between complex mathematics and strategic business output. The market does not need isolated coders running scripts in a silo. Corporations require practitioners who can align high-level sector goals directly with raw data sources. National-scale economic transformations rely entirely on the individual practitioner's ability to map algorithms to measurable business value. To understand how you deliver that value, we have to look at the corporate enterprise ecosystem and analyze the specific, multifaceted role of the data scientist. We first have to establish clear boundaries regarding what you are not responsible for in a mature enterprise. You are not a data engineer. Engineers primarily build the underlying infrastructure and maintain the data pipelines. You are also not a data analyst. Analysts focus primarily on reporting and creating historical data visualizations. This three-pillar structure clarifies your distinct position. The third, elevated pillar, represents the data scientist's unique mandate: predictive value generation and strategic problem framing. Because your primary job is strategic problem framing, skipping the initial problem framing phase completely breaks your workflow. A data scientist's core professional value is derived from their positioning at the exact intersection of predictive math and corporate strategy. We can perform a root cause analysis on that 80% project failure rate by looking at the cross-industry standard data mining lifecycle. Look at this flowchart of the standard process. We have final execution stages like data prep, modeling, and evaluation sitting here inactive. If a project fails upon deployment to the business, the root cause is almost never found in those modeling or data prep nodes. The foundational step that dictates the success or failure of all subsequent technical work is business understanding. When it illuminates, the rest of the cycle functions. Omitting this step triggers a systemic failure loop. Your data preparation becomes directionless, your modeling becomes arbitrary, and your evaluation becomes meaningless. A machine learning model with 99% accuracy is completely worthless if it violates a core organizational constraint. A superficial execution of this phase inevitably creates complex technical solutions that executives simply cannot use. The business understanding phase is the single structural pillar that prevents systemic project collapse in the enterprise ecosystem. Moving past the conceptual lifecycle, we have to look at the highly practical mechanics of this phase. The raw input you receive from corporate stakeholders will almost always be an ambiguous, high-level business problem. Watch this chaotic cloud organize into a rigid grid. This represents your primary cognitive task, translating that swirling business ambiguity into a well-defined mathematical problem. The first requirement of this translation is establishing highly specific, measurable success criteria. The second requirement is identifying hard operational and business constraints before you ever touch the data. The third requirement is selecting an appropriate algorithmic approach that strictly respects those identified constraints. Business understanding constitutes a rigorous, quantitative translation process that bounds the entire technical endeavor. There is a clear divide between the novice academic approach and the expert professional approach to solving a corporate data problem. On the left side of this diagram, you can see the novice workflow. They take an ambiguous business problem and attempt to apply complex algorithms directly to it, resulting in a negative return on investment. Now look at the expert workflow on the right. The ambiguous problem is routed through a structured business understanding translation matrix, breaking it down into success criteria, constraints, and algorithmic approach. This translation layer outputs the exact technical parameters required to reach a measurable ROI. This matrix acts as the ultimate enterprise filter, ensuring that only viable, high-value projects ever reach the coding phase. In this workflow, problem framing supersedes problem solving. Perfectly executing the wrong mathematical solution represents a massive drain on corporate time and resources. True professional maturity requires leaving the academic obsession with hyperparameter optimization behind. Correcting the framing of the business problem is the highest leverage action a practitioner can take. By mastering this translation process, you transition from being a replaceable technical resource into an indispensable driver of enterprise strategy.